Welcome to another deep dive. We're going to be talking about quantum computers today.
Sounds good.
Yeah, and everybody's talking about them, but
Now,
what are they really? And how could they actually, you know, change things in the future? And we're going to be looking at all that today using Dr. Mikio Kaku's Quantum Supremacy.
oh yeah, I love that book.
Oh, it's amazing. It's such a cool...
It lays it all out so well.
Yeah, it really does.
He does a great job of kind of explaining the evolution of computing,
Right.
and it really helps to understand where we came from to kind of see where we're going.
Yeah. And where we're going is really crazy. He talks about these three stages:
Yeah.
analog, digital, and then quantum.
Right.
I was just blown away when I read about this ancient analog computer that they found in a shipwreck.
Oh, wow.
It was over 2,000 years old.
Wow.
Can you believe that?
That's amazing.
And it was designed to track the stars.
Oh, wow.
I mean, imagine the ingenuity it took to
Yeah.
build something like that back then.
It really speaks to just that fundamental human drive to understand, the universe
Right.
and to be able to model it.
Yeah.
But of course, analog computers, even, Charles Babbage's more sophisticated
Yeah.
designs,
Yeah.
they had their limitations.
Yeah, they worked great for, simple calculations, but
Yeah.
when it came to really complex problems,
Yes.
breaking codes in World War II,
Yeah.
they just couldn't keep up.
Right.
And that's where the whole digital revolution came in
Exactly.
with Alan Turing.
Yeah.
And all of a sudden we have computers that are using transistors and binary codes.
So those zeros and ones.
Yeah, and that's, pretty much the foundation of
Everything.
everything we use today.
It's amazing to think that,
Yeah.
every digital computer, from your phone to the most powerful supercomputer, is essentially a Turing machine
Yeah.
at its core.
Yeah, it's wild. But even these incredible machines, they hit a wall when they're faced with certain types of problems.
Yeah, I did.
And that's where quantum computing comes in.
Right.
Okay, so this is where it starts to get really mind-bending.
It definitely does.
We're entering the quantum realm.
Yeah.
And this physicist, Richard Feynman,
Oh, yeah.
just a total visionary.
Visionary guy.
He was the one who proposed the idea of using a single atom
Right.
as the ultimate transistor.
Wow.
And that sparked this whole field of quantum computing, which
Yeah.
operates on totally different principles
Completely different.
than our digital world.
Right. Yeah. Feynman understood that at the atomic level,
Yeah.
it's not just about zeros and ones.
Right.
It's about electrons.
Right.
And these particles that behave like waves.
Yeah.
And quantum computers can tap into this wave-like nature,
Right.
which allows them to kind of go beyond the limitations of binary systems.
Okay, so instead of bits, we have qubits.
Right.
Okay, I get that qubits can be both 0 and 1 at the same time, but how can you help me wrap my head around that? It's just it sounds like science fiction.
It does sound like science fiction, but,
Yeah.
think of it like this. You flip a coin.
Okay.
It can land on heads
Yeah.
or tails.
Right.
But with a qubit, it can land on heads, tails, or both at the same time.
Oh, wow.
And that both at the same time idea.
Okay.
That's really the key to the power of quantum computing.
So you're telling me that this both at the same time thing is what gives quantum computers
Yes.
their crazy power?
Exactly.
How does that even actually work?
So basically, it allows these computers to perform calculations in parallel universes,
Whoa.
so to speak.
Okay.
Yeah. Similar to that
Yeah.
famous thought experiment,
Yeah.
Schrodinger's cat.
Right. The one where the cat in the box is both alive and dead until you look at it?
Exactly.
Okay, I think I'm starting to get it, but how does that translate to real world stuff?
Well, think about it this way.
Yeah.
A problem that might take a classical computer billions of years to solve. A quantum computer could potentially crack that
Really?
in a fraction of the time.
That's just mind-blowing. It sounds like this quantum supremacy thing is a really big deal.
It is.
But I also read about this challenge called decoherence.
Right.
What's that all about?
So decoherence is one of the biggest hurdles
Oh.
in quantum computing.
Oh,
It's imagine trying to balance a spinning top on a bumpy road.
oh, yeah.
Any little disturbance from the environment can knock those qubits out of their delicate quantum states.
Right.
And that leads to errors.
So how do scientists even, deal with that?
So right now, to maintain that coherence,
Yeah.
most quantum computers need to be kept at incredibly low temperatures,
Wow.
close to absolute zero.
Close to absolute zero. But wait, doesn't nature already use quantum mechanics
It
at
does.
room temperature, like in plants and stuff?
That's a great point. Yeah, you're talking about photosynthesis,
Yeah.
which is a quantum process that's
Darn.
essential for life on Earth.
Yeah.
Plants have somehow figured out how to maintain coherence at room temperature.
That's wild. So nature's already mastered something
It has.
that we're still struggling with.
Right.
It makes you wonder what other secrets nature has
Yeah,
that could, like, help us advance this whole quantum computing thing.
absolutely.
But even with this challenge of decoherence, the potential benefits of quantum computing are just
Huge.
huge.
Yeah.
So let's talk about those benefits.
Oh, great.
What are some ways that quantum computing could actually, like, change our lives?
Well, the possibilities are basically endless.
Yeah, I bet.
I mean, just imagine using quantum computers to develop more efficient fertilizers,
Oh, wow.
addressing the limitations of the green revolution
Right.
and ensuring food security for a growing population.
That's a great example. I mean, we're facing some serious challenges with food production.
They are.
And quantum computing could be a total game changer
It could.
for that.
Yeah.
What if we could create, like, stable fusion power? I mean, that would solve our energy needs
Yes.
in a clean and sustainable way.
Clean and sustainable.
That'd be amazing.
It would.
No more reliance on fossil fuels.
Right.
No more worries about climate change.
Exactly.
Quantum computers could, like, revolutionize energy production.
Absolutely.
And then there's medicine.
Right.
Quantum computers could model complex diseases at, like, the molecular level,
At the molecular level.
which could lead to potential cures for diseases that are considered incurable right now.
That's right.
Wait, you're saying that quantum computers could help us cure diseases like cancer or Alzheimer's?
It's definitely a possibility.
That's insane.
Yeah. Both exhilarating and a bit daunting.
Right. I mean, with such advancements come, ethical considerations and stuff.
Exactly.
But I'm definitely feeling like a sense of wonder and excitement about the possibilities. I mean, this is just the beginning of our deep dive.
Right.
And I can't wait to explore more of these applications of quantum computing.
Yeah, me too.
It's going to be awesome.
Yeah, it is.
All right, let's take a quick break and we'll be right back.
Sounds good.
So we've talked about how quantum computers could revolutionize food production and energy and even help us cure diseases.
Right.
What other areas could be impacted?
Oh, man. It's really hard to overstate the potential impact.
Yeah.
I mean, practically every field could be transformed in some way.
Wow.
Like, for example, materials science.
Okay.
Imagine being able to design completely new materials
Oh, wow.
with properties that we've never even seen before.
You mean like super strong, lightweight materials for building things?
Exactly.
Or maybe like flexible electronics that can bend and stretch?
Right. Quantum computers could allow us to experiment with different atomic combinations
Oh, wow.
in a virtual lab
Okay.
and discover materials with incredible strength, flexibility, conductivity,
Yeah.
you name it.
Wow.
It could revolutionize everything,
Yeah.
from aerospace engineering to consumer electronics.
That's pretty amazing.
Yeah.
It sounds like quantum computers could turn science fiction into reality.
Yeah, it really does.
And let's not forget about artificial intelligence.
Right.
Quantum computers could supercharge AI algorithms.
Allowing them to process information and learn at an exponentially faster rate.
So we're talking AI that can solve complex problems,
Yeah.
make incredibly accurate predictions,
Uh-huh.
maybe even surpass human intelligence in certain areas.
That's the potential we're looking at.
Wow.
And while that's exciting, it also raises some important questions
Yeah,
about the role of AI in our society.
right.
We need to make sure that these advancements are used ethically and responsibly.
For sure. It seems like with any powerful new technology, there are always potential risks and benefits to consider.
Absolutely.
It's like we're opening up this whole new frontier
Yeah.
with amazing opportunities, but
Yeah.
also challenges that we need to navigate carefully.
We do.
But beyond all the practical applications, there's one area that I find particularly fascinating,
Yeah.
and that's the potential to unlock a deeper understanding of the universe itself. I remember Dr. Kaku touched on that in his book.
Yeah.
He talked about using quantum computers to unravel mysteries that have baffled physicists for centuries.
Exactly. Imagine simulating the conditions of the Big Bang
Wow.
or modeling the behavior of black holes
Oh, wow.
with a quantum computer.
Okay.
It could revolutionize our understanding of cosmology and fundamental physics.
That's pretty mind-blowing. It's like having a time machine to go back to the beginning of the universe.
Yeah.
Or a powerful telescope to peer into the heart of a black hole.
That's a great way to put it.
You know, Einstein spent years searching for a unified theory of everything,
He did.
a theory that could explain all the forces and particles in the universe.
Right.
Perhaps quantum computers will be the key to finally cracking that code.
I hope so.
Wow. That would be an incredible breakthrough. It's fascinating how quantum computing could not only change our technology, but also our fundamental understanding of the universe.
It really highlights how interconnected everything is.
Right.
From the smallest particles to the largest structures in the cosmos.
Yeah.
It all comes back to the principles of quantum mechanics.
It's been an incredible journey so far.
It has.
Learning about the evolution of computing,
Yeah.
the mind-boggling principles behind quantum computers,
Right.
and all the potential applications.
And we've only just scratched the surface.
I know, that's right. This deep dive has really opened my eyes to the incredible possibilities of quantum computing.
Yeah, it's pretty amazing stuff.
Okay, my brain is like officially full,
Yeah,
but in a good way.
I know, right?
This deep dive has been incredible. We've covered so much.
We have.
I mean, ancient computers in shipwrecks, to quantum computers maybe rewriting the laws of physics.
I know, it's a lot.
Where do we even go from here?
That's a great question.
What's next for quantum computing?
Well, in a lot of ways, we're still in the very early stages
Oh, really?
of this quantum revolution.
Wow.
There's still so much we don't know.
Yeah.
And that's what makes it so exciting.
It's like we're standing on the edge of like a whole new world.
Exactly.
What are some of the big challenges that scientists are working on right now?
Well, one of the key challenges is scalability.
Okay.
Right now, quantum computers are relatively small
Okay.
and prone to errors.
Oh.
So building larger, more stable quantum computers is a major focus of research.
It's kind of like the early days of classical computers, right?
It is very similar.
They were huge and expensive and not very reliable.
Right.
But look how far we've come since then.
Yeah,
It seems like we're on a similar path with quantum computers.
I think so too.
Another major area of research is developing new quantum algorithms.
Yeah, these are the software programs
Okay.
that will really unlock the power of quantum computers,
Okay.
allow us to tackle specific problems in new and innovative ways.
So it's not just about the hardware, it's also about figuring out how to program these machines to do amazing things.
Exactly.
That sounds like a pretty tough challenge.
It is a tough challenge,
How do you-
but we're already seeing progress.
Oh, wow.
Researchers are developing algorithms for everything from drug discovery and materials design to financial modeling and even cryptography.
It's wild to think that we could be on the verge of solving problems that have stumped humanity for centuries.
It is.
From curing diseases to developing new, clean energy sources.
All right.
The possibilities seem endless.
Yeah, the
Good one.
potential is definitely there. But it's important to remember that quantum computing is not a magic bullet.
Right.
It's not going to solve all our problems overnight.
Yeah.
It's a powerful tool,
Okay.
but just one tool among many.
Right. We still need human ingenuity and creativity and collaboration to address the complex challenges facing our world.
Absolutely.
Yeah.
But quantum computing could give us a powerful new way to approach these challenges and maybe even find solutions that we never thought possible.
Absolutely. And it's not just about finding solutions, it's also about deepening our understanding of the universe and our place in it.
Right.
Quantum computing could help us unlock some of the biggest mysteries in science, from the origin of the universe to the nature of consciousness.
It's pretty amazing.
I have to admit, I was a little intimidated by the whole idea of quantum computing at first.
Yeah.
But after this deep dive,
Uh-huh.
I feel like I've gained a whole new appreciation for this incredible field.
Good. I'm glad to hear that.
It's truly mind-boggling.
It is a fascinating field, and it's constantly evolving. So
Yeah.
I encourage you to keep exploring, keep learning.
Yeah.
Who knows? Maybe you'll be the one to make the next big breakthrough in quantum computing.
Well, I wouldn't get on that.
You never know.
But I am definitely inspired to learn more.
That's great.
This deep dive has given me a whole new perspective on the future, and it's one that's filled with exciting possibilities and important questions.
That's a great way to put it. The future is what we make it. And quantum computing is just one of the many tools we have to shape that future. It's up to us to use it wisely and responsibly.
That's a great point. And on that note, I think it's time to wrap up this incredible deep dive into the world of quantum computing. I want to thank you for sharing your knowledge and insights with us today.
It's been my pleasure.
And to all of you listening out there, thank you for joining us on this journey. We hope you've learned something new and maybe even feel a little more excited about the future, just like we do. Until next time, keep exploring, keep learning, and keep asking questions.